So you see, that's what you do when you don't understand a single word of what a person said. You just smile and nod back at them. So if you guys want to stop me and ask me a question in Spanish, I'm just going to look back at you, smile, and nod, okay? No, I'm kidding. I can understand Spanish. I can't speak it, but I can understand. So, okay. Redis love Atrax. First, a little bit about me. I'm Netto. I'm Brazilian. I'm currently living in San Francisco working for Atrax. I've done a lot of stuff with Java, Ruby, JavaScript. I like working full stack. So I've tried a little iOS too. And there's no particular technology I like the most, but Ruby is one of the top ones. If you want to follow me on Atrax, atrax.com/Netto Farah, Netto at atrax.com. A little bit about Atrax. This is our office. We're a very small company in San Francisco. We're a startup. We're only 14 people as of today. It's like this really nice small space. We got this beautiful backyard. I love working from here. It's really, really cool. You got some good sunlight. And this is what we do. We're a music website where you can listen to playlists. It's slightly different from Spotify or RDO or other on-demand music services where you can just choose the artist you want to listen to or the track. As in Atrax, you can choose any kind of mood, genre, or activity. So it's playlists created by users, and you can search for the kind of mood you're in at the moment or the kind of music you want to listen to. So I could go here and I want to listen to hip-hop and rock. So it's going to present me playlists that have artists that play hip-hop and rock. You guys should check it out if you don't know it. This is what a playlist looks like. This is one I created with my indie favorites. You see there's some indie rock over there. You should just go and play it. Follow me on Atrax. Have I told you about the backyard? We love it. It's really cool. So a little bit more. So right now we got 11 million users. We got 1.5 million public playlists right now. So you can pretty much find anything. And 3.5 million playlists total. So we call it public playlists because those are the ones that are valid because we also have a license we have to complain to complain. We have a license we have to follow. So we cannot show all the tracks up front. You cannot know you can know what's the kind of music you're going to listen to, but not exactly what you're going to listen to. We have a limited number of skips, and not all the playlists are following all of those rules. So they can be taken offline or they're not ready to be published. But just to give a little more context, for the examples I'm going to give, we're going to be working on those 3.5 million. And we have right now 28 million tracks that are uploaded to the site. So you can find pretty much any kind of music you're looking for. We have no restrictions as to what artists we can play or not because we're a radio. This is not a sysadmin talk. I have only 25 minutes to talk about a lot of stuff we do with Redis. So I'm not going to get much into details about how you set it up, what you should do to scale it. I'm just going to give you examples. And this is our sysadmin getting sued up. I love sysadmins, don't get me wrong. It's about the right tool for the job. Using the right tool for whatever job, whatever feature you're building. And I love this Tumblr. People taking pictures with iPads. I go pretty much every week just to check it out. Who takes photos with an iPad? Who goes to a club and take pictures with iPads? Who goes to a conference and takes pictures with iPads? I hope this is not the case. I hope this is not like RubyConf last year. Some other conference. You know, when choosing the right tool for the job, it's all about engineering effort versus the machine effort. And with that, I mean, it's about how you, as a developer, feel. Like, how do you feel about the tools you're working at the moment? So, am I comfortable with writing Ruby or Java? Some people like Ruby and they're happy, like me. Some people like Java, and I don't know how they're happy with that. And it's also about machine effort in a way that, okay, how can we scale that tool we're choosing? How expensive is it to deploy that? How much work it's going to take to set it up correctly? So when I talk about why we chose Redis for Atrax, we have to keep in mind that I'm talking about these two different options. Well, not exactly options, because they're actually, you have to work on with them at the same time. But what I mean is you always have to keep these two things in mind when you're choosing what you're working with. But I don't really like that guy. What about this other one? We could put in another guy. We're in Uruguay, and I'm sure everyone here is a big fan of Forlan. I'm a big fan of him. Or we could give the Argentinians a chance to. I know there's a lot of people from Argentina, right? Or we could include Brazilians too. I saw a lot of guys from Brazil here. We have our chance too. And I'm sorry, Americans. You guys beat us at every other sport. Let us have our moment here. And I can't think of a soccer superstar, an American one. Anyway, so after you're done deciding, when you have a consensus on the engineering front and on the machine front, and with that, I also mean costs and management. You could fit management and sysadmins on the machine effort part of it. And there's I really love this GIF I'm going to show. It's when development tries to blame operations for the outage. I love it. Yeah. I told you guys, I love sysadmins, and that guy's the sysadmin. They're always right. The bug is always in the code. So, okay, just to summarize. The right tool for the job is when the engineer is happy and the machine is also happy. So it's all about finding this balance when you're choosing your tool. So it's when Redis come in at Atrax. I'm going to tell you guys, first, very quickly, what's Redis. I'm not going to get too much. I'm not going to bore you with the details. You have Hanno and Michelle. You can just go talk to them. They're the Redis masters right here. So it's a key value store. It's open source. It's in memory most of the time. It doesn't mean that it's always going to be in memory. You can also flush it to the disk. But most of the time, for most of the applications and most of the use, you're going to do it in memory. And it is a data structure server. And with that, I mean you can operate on data types. So you can operate on strings, lists, sets, sorted sets, and hashes. So it's that boring data structure class you had back in college, where you had to implement binary, trees, binary search, linked lists, and all of that stuff. Except it's now cool. Have you guys seen this movie, School of Rock? It's one of my favorite movies. It's really, really fun. So that's what Redis is all about. It's all of those data structures you learned, except they're implemented now, and they're really, really well done. It's scalable. It's fast. You should be able to use it very easily. So you can turn this that you learned in school, a linked list. And if you're working on Atrax, you can turn it into this. You can turn it into a linked list of Justin Bieber. And that's pretty much what I do all day. I kept picking all the Justin Bieber playlists and turn them into lists. Or we can create a list of cats, because that's the internet after all, right? That's what the internet's all about. So before I get into a little more details, things to keep in mind when you're working with Redis. Like I said, it's all in memory, but not restricted to it. You're not going to do joins or iterate over the data. I mean, it's not completely true about iterating over the data, because like, as of a few months, there's an implementation of like iterating on the data now. But when we built all of this, you could not go over all the data you have in the collection. I mean, not in a way that you could go one by one. You'd have to either like get everything or get a subset of the elements. And another very important thing to keep in mind is that you should be able to rebuild your data, because it's all in memory. If a machine goes down, or for any other reason you lose that data that's in memory, you're going to lose everything. You're going to have to be able to just rebuild that data very quickly. So at Atrax, we like to put them in two separate categories. One of them is volatile Redis, and the other one is non-volatile Redis. So some of the machines, we have replication. We guarantee that the data is always there. But for some other ones, we just rebuild the data very quickly, and we don't really care if we lose that data that's in memory. So why? Why would you use Redis? So I wanted you to keep that in mind, like that first line over there. Sometimes basic data structures is all you need. I'm going to repeat that. Sometimes basic data structures is all you need. And another reason is some problems are hard to fit in a relational way. We're used to use SQL databases. That's what comes with Rails. You have active record right away. Most of the problems you're going to work, most of the companies and products you're going to build are going to be based with SQL. And I'm not saying you should not do SQL. I'm saying you should not do everything with SQL. Only things that make sense. So this is Redis at Atrax. We love it. That's the title of the talk. You all know that. And this is what we built with Redis so far. I don't know if you... Can you guys read all of this in the back? Okay. So we use Sidekick. I'm sure that's like what most people here use for Redis. That's like one of the most famous projects running on Redis right now. We built featured toggles. So because it's so simple, it's just a key and a value. You can just choose a feature, give it a key, and you could set if it's on or off, or you could set a percentage of users you're going to use that feature. We use it for caching. We had our player. So because of the way the player at Atrax works, you cannot just go and play whatever you want. There's like a set of rules we had to follow. Well, those rules I told you about. So we had to keep state of everything that's going on within a session. So if I go to Atrax right now and start playing a playlist, I'm going to have to keep state that what was the track I played, how many skips, like how many times did I hit skip, and other things like that. So we used to do it, but we moved to CouchDB later because it was taking too much memory. Because as I told you, everything you have to fit everything in memory. So we had to fit a player for every user in memory, and that was getting a little too expensive. So we decided to move to CouchDB. For some reason, I don't know, it didn't work out that well. I was not involved in the project. And then we moved to MySQL again. And what I'm going to talk about here is going to be autocomplete and tag browsing. It's one of the two of the features we built with Redis, but those are my favorite two features. And I think they're easy enough to explain. The autocomplete will later on move to Solr, then to Elasticsearch, but for other reasons. Just because we wanted to make it a little more complex. We also built the news feed. We built our listening sessions. And we have a rate limiter for people that use our API. They're all done with Redis. And another reason why we love it is because the documentation is beautiful. It's very, very easy to understand the commands, understand the way it works, compared to understanding 100 different commands on MySQL, for example. So if you look at Redis documentation, you could fit all the commands in one page, as opposed to going to the MySQL page and seeing like all the things you can do. Here's like an example of a Redis command. It's kind of hard to read, but it's just to show what I'm talking about. So there's a title of the command, and then there's like a little explanation about the complexity of the operation you're going to be running. There are examples. There's like this interactive thing down here, which is amazing. It's going to evaluate Redis commands, and you can try it right away. It's really, really cool. So to the examples. I already talked about Sidekick. If you don't know what Sidekick is, it's just it's for background jobs. I know it's very common, like in Ruby on Rails. It's like one of the first things you do when you want to scale a Rails application. You're just going to throw everything to the background, whatever write or like heavy operation, you're going to throw it there. And it's powered by Redis. You don't need to know Redis to use Sidekick, so you can just install it and use it right away. But it's interesting to know like a little bit of the internals so you can debug it if you run into any complication. So our example. If you go to Atrax.com, there's like the search bar on the top right, and you can type whatever kind of music you feel like listening to, and it's going to return a list of results. So I just typed in indie row. I'm probably looking for indie rock, but these are the results that are going to be shown to me. So I can see tags, I can see the mixes, or I can see a collection of mixes based on that search query. So what's indie anyway? I don't know what indie is because I thought it was independent, but it turns out that it's kind of a like very popular kind of music this day. I don't know where it's indie and indie anymore. But at Atrax, this is what indie means. It could be a tag, like indie, indie rock, indie plus rock, indie chill, indie pop, whatever. It could be playlists with the name indie as part of the title. So it could be the Indie Summer, Indie Fire, Indie Meets Hip Hop, whatever. Or it could be an artist. It could be Jesus Christ, the indie band. So okay, so what's the simplest way to solve this problem if you're working on a regular Rails application? I would do this, right? Can you guys read it? Okay. So I would do select name from tags where name like int, limit 10. I'm going to bring 10 tags back. Same thing with mixes, same thing with login from users, and the same thing from artists. It's very easy, I can just do it right away. But I don't really like this approach because I'm doing like 4 selects, and then I would have to just go query 4 different tables in different like operations and then just merge all the data and show it to the users. So I could make it a little better. I could do this. I'm doing only 2 just to be a little concise, but I could do it with 4 of them, or 5, or as many tables I want to query. I could just do, have you guys done union all before? It's just so I can I can query more than one table and not join them. That's pretty much what I'm doing. I'm just getting data from tags and data from mixes, and I'm just combining all the results together. But I have a few problems with this. I can't really do cross-type search. Even though I'm doing that all thing, I'm going to run into some problems. When I'm doing union all, I cannot have different kinds of columns. So, and every table has like a different schema. So I'll have to access only, I have to make it uniform in a way that could only get the names from those tables. But after I do that, there's not really a way to know if that value came from a mix or from a tag or from a user. So it's very complicated to do that in a single select call. And I don't really want 10 of each. I want the 10 most relevant ones. And that's another very complicated problem because how do I define if a tag is very popular or if a mix is very popular or if a user is very popular in the service? Those are all, they don't fit in the same mathematical function when I'm evaluating how popular an entity in a system is. I have a different scale for users or tags. I can be a very popular user. I would need only 300 people to follow me to be popular. But if it's a playlist, it would take 20,000 plays to make it relevant. So it's really hard to fit it in one function. And as I told you, I can select different column counts. And it's also not a fair comparison. I can't compare that kind of SQL query with Redis because people don't really use databases, SQL databases, to perform those kinds of queries. They use Solr or Elasticsearch, right? But again, has anyone here ever set up a Solr server? Do you like that experience? Was it fun? It's definitely not fun. I had to do that. That was like my project right after the Redis autocomplete. It was a nightmare. It took me a month of work to just set it up correctly. There's a lot of XML. There's a lot of like natural language processing terms you need to know to understand it like really well. And it's not easy, and it goes all the way back to that, like one of those things I talked about at the beginning about engineering effort versus machine effort. And then back to one of the reasons we use it. It's because sometimes basic data structures is all you need. So is there a way I can solve this with very basic data structures? Yes, there is a way. I could use sorted sets. So sorted sets in Redis are just, it's just a set. It's a list of values. It doesn't take, they're unique values because it's a set. You cannot repeat a value. And it's sorted based on a score. So every element has to have a score, so it's the way Redis decide which way they're sorted. And it's very fast to operate on a set. Adding, removing, and updating an element all happen, and it's a log n operation. So because I don't really know how it's done, but I'm assuming it's some sort of binary search, the way you access a sorted set. So you can do it very quickly because it's sorted. You know where you should put in that value. It's easy to, it's fast to order, to test the existence, and to access any kind of element. So how can we implement that with Redis? Let's take the search term, indi, and let's break it down. So I can break it in n-grams. Those things in red and green down there, they're called n-grams. Those are the ways I can split my keyword into sub-keywords that represent that search. So I don't really care about it, I, and n. They're not really relevant for search because some people call them stop words. If n, for example, would be a stop word, it doesn't really matter. Or I is just because it's too short. It's not worth it. And then I could just get the other part, and indi and indi. So for this example, I'm going to use a very, very simple set. So assuming Atrax is only these three mixes, Indi Summer, Indiana, and Industrial, just to make it simpler to understand. What we can do is we can create one sorted set for each of the n-grams. So for the key end in my sorted set, I'm going to have those three playlists. I'm going to have Indi Summer, Indiana, and Industrial. For end, I'm going to have Indi Summer and Indiana. And Industrial doesn't really matter anymore because it's INDU, right? And then for Indi, I only have the Indi Summer because Indiana, it's not in there anyway. It's not a combination. Like it's not an n-gram within Indiana. So if I can do this for every mix, for every tag, for every user and collection and artist at Atrax, I could just create these n-grams and store all of the results. For each one of those keys, I can store all of the results. And then querying it, it's very, very easy because I can just go and fetch a key. So as if you're using a Ruby hash, your search term is going to be your key, and you're just going to send it to Redis and, hey, give me whatever matches this guy. And because it's a sorted set, you know what's like the most relevant ones are going to come in first. So you created a very simple search, autocomplete search, from left to right very easily, just using zsets. And implementing this is very, very easy. If I want to add Indi Summer, every time when I create the Indi Summer playlist, what one of our background jobs is going to do is that it's going to break it down. It's going to break it down at end, Indi, and Indi, and it's just going to insert it. And in that list. And it's going to give it a score. And a score could be any mathematical function you want to do. So in this case, we're just sorting it by the number of times that playlist was played. So if it was played 1,000,000 times, the score is going to be 1,000,000. And then searching is also very easy. I can just use there's a typo here. It's supposed to be zrev range. I'm just going to get a range from that list I just created, passing in the key, and it's going to return me the values. So I just turned all of those like 4 or 5 or 6 database queries into a single query on the list. And because it's a key value store, I'm just going to give it the key, and it's going to give me back the value. Cool. So the second example is a little more complicated. It's tag browsing. Tag browsing is the most used feature at Atrax right now. 60% of our streaming comes from this single page. If you go to atrax.com for the first time, you're going to be presented with this tag cloud. If you're a second-time user, you could go to atrax.com/explore, and you can explore the whole catalog we have. So these are the top tags the user is presented with. So let's just say I want to listen to chill and acoustic. I want to listen to like acoustic music, and I want to chill out. How can we do that in a regular database? It's actually not hard to do. We can come up with this schema. I have a tags table. It's only got like a name and ID, mixes or playlist table with names and IDs. And it's an end-to-end relationship, right? Because a mix can have many tags, and a tag could show up in many mixes. So there's a tagging table that you can just apply a tag to a mix, which is very simple. It's easy to use. We could prototype it very quickly. And then how do we query that? If I want to listen to chill, I'm just going to select everything from the mix. I'm going to inner join it to tagging, and then the mix ID and the tag ID. The tag ID must match the tag I'm looking for. So just to make it a little simpler, I turned then to assuming we know the ID up front, but we don't really know, because you could do atrax.com/explore indie or chill or whatever, chill in this case. We'll still have to look up what's the ID for chill. So I could include that in this select call. But just to fit it better in the slide, I'm just assuming we already know. It's fairly easy. We can do that very quickly. We have indexes, mixes and taggings, and the tag. It's very, very quick to just go and query it. If you have 2 tags, how do you join with the same table twice? One way to do it is to use inner joins, and you can join once and then join again. So we inner join taggings to mixes and taggings to mixes again. We do the join part right after the inner join. We actually match the IDs. And then where the tag ID equals chill, and the other one where it's equal acoustic. Which is okay too, because you have all the indexes. You can just run this very quickly. But if I'm exploring 3 tags, that's an extra inner join. If I'm doing 4 tags, an extra inner join I'm going to have to do. It gets more and more complicated. And it's also not very developer-friendly. Because one thing we saw with the autocomplete is that you don't have to switch your brain to database mode when you're working with Redis. It's all data structures. It's all that Ruby you're used to writing. You could just iterate over a collection. You can just put something in there, get it back. You don't have to change your mind into database mode. And you don't have to know all of those crazy commands like union all, or what's the difference between a left outer join and right outer join, an inner join, a full join. I always have to go and look up and see those Venn diagrams where it shows what kind of join. And so far, okay. So far, it's okay. But what if I have to add sorting to this result? Because I just don't want any acoustic and chill playlists. I want the best playlists. I want them to be on the first page. So I add sorting. I add that extra line down there. So I picked the simplest one, which is recentness. I want to see the most recent ones. And that's actually part of the mixes table. So it's very easy to just go and do order by. But it could be more complicated. I could be sorting by trendiness or popularness of a mix. And the way it works at Atrax today, they're in different tables. We have like a mix stats table where you could just see how popular or how trending that mix is. And that would add another join to this. And we could argue and just say, you know what, just add those fields back to the mix table. Yeah, we could do that, except that there are 3.5 million rows in that table, and the site is live, and we're going to have to run that migration. And that's going to take the table down. You can't just keep accessing the table. You could come up with like many solutions for that. You could do it on a separate database and then just switch them again and then just send the data over to the other one. There's a lot of solutions. A lot of smart people came up with those solutions, except they take time and they take money. You have to have an extra database to take all the load at that time. So, okay, and if you run this, it's not just working on, it's still working on those indexes, but it's not just getting 10 results. It's going to have to sort them, all of them again, to pick the 10 best results. And this takes a long time. And, all right. What should we do? There's a beautiful Redis command that we can use to solve this problem. I'm not going to give much of the details here because it's a little complex to fit it on the screen. But if you're curious, you could just go and check it out. It's called zsets. So what it does pretty much is it intersects two sets, then store them in a new different set. And it's got a time complexity. It looks very ugly and hard to understand. But don't worry, we're going to get to this. Don't worry about it right now. So let's just try to think of the problem in a different way. We could think of it in terms of buckets. So instead of thinking about the mixes have tags and tags have mixes, let's just try to think it differently. Let's not think in a relational way. Let's just assume there's a bucket called chill. And we can fit everything that's tagged as chill in there. And that's our Z set again. It's a sorted set with a lot of elements in it. And the same thing for acoustic. It's another set. It's got a lot of playlists inside. And what we want to do, at the end of the day, we want to combine these two guys. That's in set theory. That's just a set intersection. I'm using the wrong symbol here. It should not be a plus. It should be an intersection symbol. I'm sorry. Because that's actually union. I'm not actually union. Yeah, like not performing a union operation. I'm actually intersecting. But it's going to be a little clearer here. So this is what we're doing at the end of the day. We have a chill set, an acoustic set, and we're merging them together. So the red part is the part that actually matters for the user. So you see in a command, it's very easy to do it in Redis. The interstore takes a cache key. Remember that cache I told you about? Is that the resulting set? It has to have a key because it's a key value store. Then, as a second param, you have to pass in what are the sets you want to intersect. And that's very easy because I just have a key and a value. I can just use the name of the tag as the key. So I don't have to do that extra lookup now to know what's the ID. I can just throw it right away. And then that's just an array of the two sets I want. And then there's this last param. It's very interesting. Those are the weights you want to apply to each one of those sets. So here, don't worry about it much. We're just doing 1 and 1. That means they're equally important. So it doesn't really matter. So cool. But that doesn't solve the sorting problem. That's still the same thing we just did with the database, but we did it differently. This is how we sort it now. So assuming there's a chill linked list with everything, and it's sorted. There's an acoustic linked list with everything that's tagged acoustic, and it's sorted. There's also a big, very, very big set which contains every single playlist at Atrax, sorted by popularness, right? So now it's just a matter of intersecting the 3 of them and we're going to have to, inside popular, we're going to have to find every single playlist that's tagged chill and acoustic. And now you can see that the weights param, that's where it comes in handy. Because we're just going to say ignore chill and acoustic. They are the two last elements in the array. And use the popular score. So I'm just telling it. I don't care about the scores for chill and acoustic. I care about the scores on popular. So get me the first. Just go and intersect all of those guys and sort them by their popular score. Because I have everything. I know the scores for everything. Now, back to that big old thing. We know it's n times k plus m log m, where n is the smallest input. So assuming acoustic was the smallest set, we know we're going to do n operations for like traversing that guy times the number of sorted sets. I'm intersecting 3 of them. And then I'm going to sum that to m log m being the number of elements of the resulting set. So we know it's not that expensive because we know it's going to have less elements than any of those 3 sets, except if every mix that's tagged acoustic is also tagged chill. That would be the worst case scenario. But anyway, it's not that hard of a problem for Redis to process. And at the end of the day, this is what we got. So if you go to Atrax right now and browse this, you can imagine all of that happening right now. And you see that these 2 guys show up first, which are these guys. You can see that one of them was in acoustic. They're both in acoustic, and they're both in chill. You can see the guy with the guitar and the heart down here. They're back here. So that's everything that intersects. Those other results are also intersected, but because they're like so deep down to the list, there was no way to show in the slides. Cool. So that's it for the examples. Like I told you guys, we did like a lot of stuff. So if you have any more questions, you can just ask me at the end of the talk or later. Some cool things you should check out are pipelining. So because it's always an operation, every time you perform an operation, it has to go to Redis and come back. There's a way you could do that. You could just pipeline all of those calls. So you could give it like 500 commands and just tell Redis, hey, execute this 500 guys. I don't really care. Just give me the result back in the end. There's also Lua scripting. If you want to do something straight in Redis, if you want to save calls to the Redis server you're running, you can just go and write the scripts you want to run. And so it's like a little like stored procedures in database, except it's cool. And replication and persistence is also another thing that's worth checking out. Because it's all in memory, and if you can lose the data, you want to have it backed up somewhere else. You may want to just save it to the hard drive, or maybe you want to have it in a separate box that you can just flip if something goes wrong. And the lessons we learned at Atrax, it consumes a lot of memory. And that's obvious, because it's all in memory. So you have to keep that in mind. All of your data, it's going to be there. So if you don't have a lot of memory in your machine, you can still run it, but you cannot put too much data in it. You can use Sentinels for failure recovery. We use it right now in production. It's a very nice project. It's open source. It's on GitHub. You can just go and look for it. It's going to replicate every single machine you want it to replicate. And then if something goes wrong, it just automatically switches it. Do not use keys in production. If you look at the documentation of the keys command, it says, do not use this in production. It's meant for debugging. Of course I used that in production. Of course I did this. And I took the website down for an hour because it took all of the Redis boxes down. Because it has to go through every single key. And I was really stupid because there are millions of keys and I wanted to see all of them. I don't know why. And duplication could be tricky. Sentinel is awesome, but we had a really hard time getting it to work right. So it's beautiful. It's very easy to use, but once you get it live, it could be a little tricky just to get all that data available all the time. And that's it.